Good morning, children. Today we will learn about the colloid. This is second topic in surface chemistry. As we have seen earlier, that surface chemistry involves the study of surface phenomenon, in which first we have seen the adsorption, its types, and how the adsorption can be classified and what are the various applications of adsorption. Now children, they will learn about the colloid. Now what is colloid? Actually, initially Thomas Graham classified the substances in two categories. One is crystalloid and another is colloid. And this classification of Thomas Graham was quite arbitrary. Actually, Thomas Graham took the substances in the form of their solution and then he passed the solution through parchment paper or cellophane membrane. Then what he notices that there are certain substances which can pass through cellophane paper quickly. Such substances were called crystalloid, and there were certain substances which in the form of solution either passed very slowly or do not pass. Thomas Graham called such substances colloid. For example, when he took sodium chloride in aqueous solution form, then जब सोडियम क्लोराइड सॉल्यूशन को पार्चमेंट पेपर में उसकी बैग में रखा गया तो ये बहुत ही क्विकली ट्रिकल हो गया, नीचे ट्रिकल डाउन हो गया, आसानी से पास हो गया. और जब हम गम जिलेटिन के सॉल्यूशन को पार्चमेंट पेपर से जब हम पास करते हैं तो ये बहुत ही स्लोली पास हुई. तो थॉमस ग्राहम ने आर्बिट्रेरी NaCl को MgCl2 के एक्वस सॉल्यूशन को इनको उन्होंने क्रिस्टलाइट कहा, जो कि आसानी से पास हो गए, और जो आसानी से पास नहीं हुए उनको उन्होंने कोलॉइड नाम दिया. लेकिन बाद में इस आर्बिट्रेरी क्लासिफिकेशन को डिस्कार्ड किया गया, ओवररूल्ड किया गया, और ये पाया गया कि किसी भी सब्सटेंस का कोलॉइड या क्रिस्टलाइड होना उनके किसी मेम्ब्रेन से पास होने पर डिपेंड नहीं करता है, बट इस बात पर डिपेंड करता है कि उस सॉल्यूशन में जो पार्टिकल है, जो डिस्पर्स्ड फेस है, उसकी साइज क्या है. सो इफ द पार्टिकल साइज ऑफ द सब्सटेंस इन सुटेबल मीडियम इज फ्रॉम 1 nanometer to 1000 nanometer, then we call such substances as colloid. Now, if the particle size in suitable medium is lesser than 1 nanometer, then such substance is called crystalloid. And if the particle size is greater than 1000 nanometer, then substances in dispersed form is called emulsion. So now the substances can be colloid, can be crystalloid, can be emulsion based on the size of dispersed phase or based on the size of solute particles. If the particle size ranges from 1 nanometer to 1000 nanometer, then it is called colloid. If it is lesser than 1 nanometer, then it is crystalloid. Crystalloid solution is also called as true solution. Crystalloid is also called as true solution, and if particle size is more than 1000 nanometer, then it is called emulsion. So as we know that solution is always homogeneous in nature, but colloid and emulsion, these are heterogeneous, where colloid is comparatively more stable and emulsion is highly unstable because the particle size is larger enough. So when we keep the emulsion, then the dispersed phase or solute particles settle down because they are larger in size. So due to the gravity action, they settle. So emulsion is highly unstable. Now we can say that any substance can be colloid if its particle size ranges from 1 nm to 1000 nm. It is not that such substances are colloid and these substances are colloid and NaCl, MgCl2 they are crystalline. It is not like that. Any substance can be made colloid. Any substance can be colloid if in the suitable medium its particle size ranges from 1 nanometer to 1000 nanometer. As we know what is 1 nanometer? 1 nanometer equal to 10 raised to the power minus 9 meter, or this is equal to 10 raised to the power minus 7 centimeter. तो अगर किसी भी डिस्पर्स्ड फेज की पार्टिकल्स किसी भी सॉल्यूशन में अगर इस रेंज में आएगा 1 नैनोमीटर टू 1000 नैनोमीटर, तब हम उसको क्या बोलेंगे? कोलाइड बोलेंगे। तो कोई भी सब्सटेंस कोलाइड हो सकता है। फॉर एग्जांपल अगर हम NaCl की केस में, तो सोडियम क्लोराइड इज ए टिपिकल क्रिस्टलाइड इन एक्वस सॉल्यूशन। अगर हम इसको एक्वस मीडियम में लेते हैं तो ये एज ए क्रिस्टलाइड बिहेव करता है, लेकिन जब हम NaCl को बेंजीन में रखते हैं तब ये एक कोलाइड की तरह बिहेव करता है। सब्सटेंस एक ही है, लेकिन ये क्रिस्टलाइड भी हो सकता है और कोलाइड भी हो सकता है। तो किसी भी सब्सटेंस का क्रिस्टलाइड होना या कोलाइड होना उनके मेम्ब्रेन से पास होने पर डिपेंड नहीं करता है, बट इस बात पर डिपेंड करता है कि उसमें जो सॉल्यूट पार्टिकल्स हैं, जो डिस्पर्स्ड फेस है, जो डिजॉल्व हुआ पार्ट है, उसके पार्टिकल्स की साइज क्या है। अगर वो जैसे NaCl को अगर हम एक्वस सॉल्यूशन में रखते हैं तो ये कंप्लीटली डिसोसिएट होता है और यहाँ पर जो साइज ऑफ पार्टिकल्स आता है वो लेस देन 1 नैनोमीटर होता है, क्योंकि हम जानते हैं कि NaCl अगर एक्वस सॉल्यूशन में लिया जाएगा तो ये डिसोसिएट करके Na+ और Cl- में कन्वर्ट होगा, जिसका जो साइज होगा वो लेस देन 1 नैनोमीटर। बट NaCl एक आयनिक कंपाउंड है। अगर इसको हम नॉन पोलर मीडियम में बेंजीन में रखते हैं तो इस समय जो साइज ऑफ पार्टिकल्स है वो 1 नैनोमीटर टू 1000 नैनोमीटर के बीच में रहता है। तो ऐसे कंडीशन में NaCl बेंजीन मीडियम में एज ए कोलाइड बिहेव करता है। सो एनी सब्सटेंस कैन बी कोलाइड इफ इट्स पार्टिकल साइज इन सुटेबल मीडियम रेंजेस from 1 nanometer to 1000 nanometer. Now we will take how the colloids can be classified. Classification of the colloid. Classification of colloid. So there are different ways by which the colloids can be classified. First classification is based on physical states of dispersed phase and dispersion medium। तो इसमें ये जानना जरूरी है कि जो हमारा कोलाइड है, कोलाइड इज ऑलवेज हेटेरोजेनियस इन नेचर। सो इट कंसिस्ट ऑफ 2 phases, कोलाइड is heterogeneous. It consists of two phases. One is dispersed phase. Dispersed phase, and another is dispersion medium. So colloid, which is always heterogeneous in nature. Hetero means different, geneity means phases, components. So colloid, which consists of different components, which consists of different phases. So here one component is dispersed phase and another component is dispersion medium. What is dispersed phase? The substance whose particle size ranges from 1 nanometer to 1000 nanometer, that is called dispersed phase. This is the component of the colloid which is present in less amount. So the component of the colloid which is present in less amount, whose particle size ranges from 1 nanometer to 1000 nanometer, this component is called dispersed phase. Now dispersion medium. So it is suitable medium which has ability to convert this is the colloid consists of two phases, dispersed phase and dispersion medium. Now dispersed phase is present in lesser amount and its particle size ranges from 1 nanometer to 1000 nanometer. Dispersion medium is suitable medium which has ability to convert the dispersed phase in the range of 1 nanometer to 1000 nanometer, and this is present in larger amount. So the component which is present in larger amount and has ability to break the lump of the substance of the dispersed phase in the range of 1 nanometer to 1000 nanometer. This is called dispersed phase. Now, dispersed phase and dispersion medium can be present in any of the physical states. So now let us see how the colloid can be classified on the basis of physical states of dispersed phase and dispersion medium. I think now it is clear, children. What is dispersed phase? The component of the colloid which is present in lesser amount और जिसके पार्टिकल का जो रेंज है वो 1 नैनोमीटर टू 1000 नैनोमीटर में हो. डिस्पर्जन मीडियम ये सुटेबल मीडियम होता है जो कि डिस्पर्स्ड फेज को इस रेंज में, कोलॉइड के रेंज में कन्वर्ट कर देता है. जैसा आपने देखा था पहले भी कि NaCl जब हम लेते हैं तो उस समय water cannot be suitable medium to convert NaCl in the form of colloid, but it is benzene which can convert NaCl in the form of colloid. तो हम ये कह सकते हैं कि here the benzene is suitable dispersion medium which can convert NaCl in the range of colloid. So now let us see the different types of colloid based on the physical states of dispersed phase and dispersion medium. तो यहाँ पर हम सीरियल नंबर लिख लेंगे. सीरियल नंबर, फिजिकल स्टेट ऑफ डिस्पर्स्ड फेज, फिजिकल स्टेट ऑफ डिस्पर्जन मीडियम, और जो कोलॉइड होगा उसका कॉमन नेम क्या होगा, एंड एग्जांपल्स ऑफ that type of colloid. So first we will take if the dispersed phase is solid and dispersion medium is also solid. So this is called solid in solid, and such colloid is called as solid sol. And the example of this type of colloid is colored glasses. Colored glass, gem, stones, etc. Now if we take the second case where the dispersed phase is again solid but the medium is liquid. Now solid dispersed in liquid, then it is called as sol simply, or liquid sol. Example is as starch, sol, gold, sol, etc. Now we will take the third case where again the dispersed phase is solid but the medium is gas. This is called aerosol. Air, as the gas is present in larger quantity because it is dispersion medium, so appearance will be just like air. So this is called aerosol. As dust or sand in air, that is called aerosol. So here we have seen the dispersed phase is solid, but the dispersion medium can be solid, liquid and gas. Now we will take where the dispersed phase is liquid, but the dispersion medium is solid. So liquid dispersed in solid. So solid is present in larger quantity. तो appearance क्या होगा? Solid like appearance होगा. तो इसका common name क्या होता है? Gel. As fruit jellies. Fruit jellies belong to this type of colloid. Now next, if we take here again we have liquid, but now liquid dispersed in another liquid. So liquid in a liquid dispersion, liquid dispersed in another liquid. This is called emulsion. Liquid dispersed in another liquid. This is called emulsion, and the example is as milk. This is the example of emulsion: milk, curd, liver oil, butter, etc. तो ये सब हमारे liquid type of colloid. Now we will take where next case fifth. Now it is sixth where liquid is our dispersed phase and gas is the medium. Liquid dispersed in gas, again it is called aerosol, as mist in air. So now here we have seen if the liquid is the dispersed phase. Now next is where gas is the dispersed phase but the medium is solid, means gas dispersed in solid, so it is called solid foam. Solid foam. So here in solid foam we have the example as pumic stone, rubber belong to this type where the gas dispersed in solid. Now we have the next eighth where we have a gas. Now the gas dispersed in liquid. So this is a liquid foam. Liquid foam as soap, lead, or whipped cream. So these are 8 types of colloid based on physical state of dispersed phase and dispersion medium. Now what will happen if we take next where the dispersed phase is gas, dispersion medium is also gas. So can gas in another gas form the colloid? So answer is no. A gas in another gas always mixed homogeneously and we get homogeneous mixture, and any homogeneous mixture is called as solution. So it cannot be colloid. So this is classification based on physical states. Now next we will take the classification of colloid based on the nature of dispersed phase particles. Second classification is based on nature of dispersed phase particles. So based on nature of dispersed phase particles, colloid can be classified into three types. First is macromolecular. This is very important classification. Macromolecular colloid. Second is macromolecular colloid, and third is associated colloid. So let us see this classification. Macromolecular colloid, as the name indicates, the individual size of the particle is lesser than 1 nanometer. So when they are put in the medium, these particles get aggregated to form the aggregates of colloid range. For example, gold sol, sulfur sol form micromolecular colloid because the individual size of gold atom is very small. So when a large number of the gold atoms aggregate together in the suitable medium, then they come in the range of colloid that is 1 nanometer to 1000 nanometer. So this type of colloid is called micromolecular colloid. Now coming to macro. As the name indicates here, the size of the dispersed phase is itself in the range of colloid, that is 1 nanometer to 1000 nanometer. They are itself bigger in size to have colloid dimension. For example, as protein sol, polythene sol, polythene sol. So here you will see that the size of star sol itself is star sol. So here the size of particle itself is large. They are macromolecular. They are macro means large in size. So they have the colloid dimensions. Organic sols, polypeptide sols, protein sols, gelatin sols, polythene sol belong to this type. Now the very important is this associated colloid. What is associated colloid? There are certain substances which when put in the medium in lower concentration, then they behave just like a strong electrolyte. What is strong electrolyte? That is just like NaCl when it is put in water, so it dissociates completely. So similarly, there are certain substances which in